Smalltalk is a programming language that was created at Xerox PARC as a software for their vision of what personal computing would be. So Smalltalk was one of the first object-oriented programming languages, and it wasn't just a programming language, but an entire software authoring environment that was highly influential in the history of the GUI, in the history of what you see, what you get editors, as well as many of the metaphors that we use today for UI design.
Yeah, and this is kind of hard to get a grasp on unless you've watched some demos or tried it yourself. But I guess it's akin to that Steve Jobs quote about like that thing that changed his life was that when he looked at everything around him, he realized that somebody had to design and make it. And so if you're like, those people are not that special, then that means that I can change the things that are around me. Like it's kind of a similar attitude to Smalltalk. It's extraordinarily powerful. It makes you feel like you're in the system and you can touch everything that you see.
Hey, this is Sri.
And this is Will.
Welcome to the Technium, where we talk about the edge of technology and what we can build with it. An optimistic look at the road ahead. How's it going, Will?
I'm doing well. This time I went back to Whole Foods and I got something called Steez.
Steez, okay.
An antioxidant brew, and it's peach flavored. And I just noticed that it's got T in the middle of the name.
Nice.
Hence it's a T, right?
Puns.
Steez.
Cool. And any purported health benefits?
Antioxidant, we believe, blah, 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 premium fair trade. I think it should have been called Steep. Right? More clever.
Yeah.
I'll give that one out for free.
There we go. Well, I also went to Whole Foods and I got this alive, ancient mushroom elixir. It's got these ancient...
That sounds disgusting, but let's see.
Yeah. I hope it doesn't mean the mushrooms are ancient, but more that the elixir concept is ancient.
You're right.
But we'll see.
Right.
We'll see.
That's cool. So what are we talking about this week? Oh, we have something special for our listeners this week.
Yes.
Our listeners this week.
So for the first time, we are doing an episode that is looking back into the past and looking at it from the lens of what did people in the past think about what the future of computing was.
A retro future. So if you've ever seen those gleaming images in the 50s of like the sleek chrome-filled towers and cars, like that's what the people in the 50s thought today or their future was going to look like. And today we're going to cover the retro future.
Yeah, exactly. And so a really great place to start is with talking about Smalltalk. So Smalltalk is a programming language that was created at Xerox PARC as a software for their vision of what personal computing would be, for a concept called the Dynabook. So Smalltalk was one of the first object-oriented programming languages, and it wasn't just a programming language, but an entire software authoring environment that was highly influential in the history of the GUI, in the history of what you see, what you get editors, as well as many of the metaphors that we use today for UI design. So it's a very, very influential project, and so I'm super excited to talk about it.
Yeah, I mean, if you've done any object-oriented programming, I mean, the lineage can be traced back to Smalltalk, which it has its influences as well, but those previous influences didn't have as much of an impact as Smalltalk did. And we'll talk about object-oriented programming. Alan Kay, it's one of its inventors, had wanted it to be, and what we ended up learning in the rest of the industry, and like what the diff between their vision and what the world came to be. Yeah, that's one of the interesting parts of our conversation.
Yeah, so spoiler alert. It didn't quite pan out the way that they thought it would be, neither the Smalltalk project itself, or I might say the entire course of personal computing did not turn out the way that they expected it would. So it's going to be super interesting to talk about.
Yeah, which is funny because he's quoted as saying, like, the only way to predict the future is to invent it. And they invented it, but it didn't turn out the way that they thought.
Yes. Yeah, exactly. So we'll go into all of that. And yeah, so, just as an overview, Smalltalk was created at the highly influential research lab Xerox PARC. The name most commonly associated with Smalltalk is Alan Kay, who was its sort of designer, inventor, and sort of it's his brainchild, but there were many other people who were involved that we'll reference. So it was obviously a big team effort, but it was Alan Kay's vision that started it all. And so I actually wanted to start there. So Alan Kay's vision for Smalltalk was that it would be a programming environment that'd be easy to use for children, and specifically for children to use on this futuristic tablet-like personal computer called the Dynabook. So they were trying to build a computer that was meant to be a personal dynamic medium, in contrast to the computers of that era, which were mainframes and business machines. And so personal computing meant that it was an environment that could be tailored to the interests and needs of the user, rather than more of a corporate type of machine.
Yeah, and so a little bit of background here to pause here for a second, why Alan Kay cared about making programming accessible and teachable to children. It's because like when he was involved in computing in the 60s, I want to say, yeah, like when he like graduated school and he's like working in computers, like at that time, like Sri just said, the only places that had computers were universities and like large companies, and they were all mainframes and stuff. And as he worked in it more, he came to understand that if Moore's law was true, then these things were going to get faster and faster and smaller. So the implication is that you're going to have a personal computing for almost everybody on the planet. And if that were the case, then like you needed people to know how to use these computers. But like beyond that, not just computers as tools, like he saw an entirely new medium in the same way that like television was an entirely new medium. And, you know, people have argued about the pros and cons of television for the better part of the kind of decades. And in the same way that Mr. Rogers saw the television and he saw its potential as a way to educate children for the next like generation, for the next set of challenges to come, like Alan Kay saw the computer as a medium in which people needed to understand like how to author it. It's like computer literacy, like computational literacy, not just computer literacy, but like computational literacy is what he was going for. So that's where he's coming from. And he also thought that like children were much more demanding as consumers. And so if they can make it work for kids, then everybody else should be fine.
Yeah, interesting. Yeah, I think when we're talking about computational literacy, there's this vision that you can see throughout that is sort of related to our previous episode of end-user programming, which is that not only are you literate when you can read, when you can consume the medium, but also when you can write back to the medium. And so Smalltalk threaded throughout, there's this idea that it exposes a way to interact with it, to modify it as you use it, and there's actually no distinction between the mode of using and the mode of building. It's sort of debug mode is the only mode is one way that I've heard it characterized. And so very different than how we use computers today.
Yeah. I would say so. So where do we go from here? Like given their Alan Kay's vision for Smalltalk, where do we go from here?
Yeah, so there are a couple of things that we should get out of the way. The first is the fact that I mentioned before that Smalltalk is known as one of the first object-oriented programming languages, and they sort of came about it through a very reasoned way. So they have a set of design principles that was outlined by another one of the Smalltalk creators, Dan Ingalls, which is that they wanted the system that Smalltalk provided to be entirely comprehensible by a single individual. And a key component of that was to make the system modular, meaning that rather than having the code and the system be this highly interlinked, intermeshed ball of twine, they wanted the system to be reasoned about in an easy way. And so the way that they came up with how to do that was that they were going to decompose the system that's running on your computer into smaller components that they called objects. And an object would be a sort of self-contained thing that they thought of as a sort of mini computer, and it would have its own state and its own logic. And you would build a system by making objects send messages to each other. So you'd have an object, and it wants another object to do something, and it would send a message saying, hey, can you do this thing? And that object would either do it, or maybe it doesn't know how to do it, and it would send an error message back. But the whole system was composed of these talkative objects that were requesting things of each other, and that's how you'd compose the system.
Yeah, when I learned object orientation back in, I don't know, college or high school, I did not get any of this. Like none of this like idea filtered through. Did you get any of this when you were like learning OOP programming?
No, I mean, if you look at the way that OOP is taught these days, or maybe actually for the last few decades, the main examples that you get are that there are objects and classes descend from each other, and a dog is a
the dog is a kind of animal, and it's completely unhelpful as an example. And it teaches like the inheritance part. It focuses on the inheritance rather than the message passing part, which I guess is besides the point apparently.
And so object oriented programming these days is very focused on inheritance and sort of the polymorphism aspect, meaning that you'll have things that you override a method and you have like a general interface that it exposes and things like that. And Alan Kay actually wrote in like one of his mailing list posts that the big idea about Smalltalk is not objects. I'm sorry I long ago coined the term objects for this topic. He literally says that. He regrets this. And he says that the big idea is that it's about messaging, that the key to making great and growable systems is how its modules communicate rather than what their internal, how you represent them in the code. And so that's the big idea. You decompose the parts of your running system into things that can handle parts of their logic independently, and they talk to each other through sort of this well-defined, messaging layer. And that way you can sort of partition parts of the functionality off, and then you also make it so that rather than having all parts of their system know the internal state of everything, they can sort of maintain abstraction. Because in Smalltalk, all of the state within an object is private, and you can only send messages to it, and maybe it will send back a representation of its state if you ask it. But you can't go into an object and modify things, and so it kind of keeps it clean.
Yeah, when I first read that post and his description of object orientation, I was like, oh, that sounds like the actor model. Yeah. And it turns out that Carl Hewitt was very much influenced by Smalltalk also. So for those of you that are Erlang and Elixir programmers, like the actor model is actually inspired and takes away from the OOP, but I think they got the vision right. I guess they got the message. Like they feel like
literally and
passing.
metaphorically, yeah.
Right.
Yeah.
Right. Literally and metaphorically. And so I guess for those of you that don't know what actor models are, we'll put them in the show notes. Yeah. So the actor model, I think, is closer to the original intention of object-oriented programming. I think the other thing that I came to realize when doing research for this podcast was the state of the art at the time was a lot of low-level programming. Like people were like messing around with memory, like things in memory with pointers. And I guess it's still how like system programming is done today in C and stuff like that. And like this, it must have taken some amount of leaps. There had to be multiple leaps for them to say, okay, we're going to take this low-level stuff and we're going to construct an entire environment in which you don't really need to worry about these sort of things, and you only do when things run too slow. But everything is passing messages. Yeah. And I think it does. They didn't have to go that far though, because they did take inspiration from Lisp. I think definitely Lisp is a language that's well known to not worry about computation in the practical sense of how they're going to be run on machines, but like they're more worried about like what is the theoretical limits of computation as an abstract.
Yeah, Alan K.
I think Smalltalk
mentions that
has that lineage.
Yeah, Alan K. mentions that he appreciated the fact that in Lisp there was this metacircular aspect of it, meaning that in Lisp the code itself is a data structure that it can parse and modify, and that gives it a lot of special properties. And so in designing Smalltalk, he was thinking about how can we make that kind of recursive metaphor, and they came upon this recursive metaphor of objects, meaning that within your computer you have these, like I mentioned, these mini computers that are each running their own processes, and they talk to each other. And it's interesting because maybe in later years after the internet came out, Alan Kay repeatedly makes a reference to the fact that you should think of these objects as computers that are talking to each other over a very fast network. And so I'm curious whether they sort of made their original Smalltalk environments with networks in mind, or whether that was a metaphor that emerged later. But all the same, it's a very kind of interesting way of thinking about objects that we don't think about today.
Yeah, I was a little curious about that too, and maybe like that's why Erlang looks the way it does, because like it kind of took this message passing to heart across like actual computers, and they made it literal. And all the attempts in the 90s of trying to hide remote code execution failed, because it's just a completely different thing to try to like execute code on remote machines. Like you have all sorts of things that could fail, and it's really hard to hide that in a abstraction that's in the guise of like a method call on the same computer. Yeah. And so I think, and then to your point about the concept of Smalltalk as a metacircular evaluation, like he also did make the connection to Platonics, like Plato's cave, in which the ideas are like classes are effectively ideas, and these ideas in which you can make manifestations. And so that's the instantiations of these ideas. Yeah. And the ideas themselves are manifestations of the idea. So it's the object class, I think, right? Or the class. Right. And then that the idea is a kind of a manifestation idea. So like that's how he kind of got it to reference itself. And so the first time I happened upon that was in Ruby, where I was looking at their object model. I'm like, oh, this is weird. Yeah. Like at the very top, it just kind of folds back in on itself. But I mean, Mats didn't come up with that. Like he was taking it literally from the Smalltalk tradition. Yeah,
it's a very powerful concept, and that's another aspect that I wanted to go into, which is the fact that Smalltalk is not just a language the way that we think about programming languages today. It is a language that is supposed to be coupled with a whole environment, and that environment is your computer. It's GUI. It's the processor, all of those things are actually represented as Smalltalk objects. And so what it means is that if everything is a Smalltalk object, you can actually go and query the state of your system, and you can interact with your keyboard as though it's an object. You can interact with your screen as though it's an object that has a render method or a draw response to a draw message. And so what it means is that you can actually go and change parts of your environment that today, actually, we would think of as being part of your operating system. There are parts that you can't go into because they are sort of special in some sense, separate from your own programming logic. But in Smalltalk, everything is an object. Everything is exposed as an object. And so you can interact with them just as you would any other objects that live within your own program, so to speak.
Yeah, and this is kind of hard to get a grasp on unless you've watched some demos or tried it yourself. But it's just literally, I guess it's akin to that Steve Jobs quote about like that thing that changed his life was that when he looked at everything around him, he realized that somebody had to design and make it. And so if you're like, those people are not that special, then that means that I can change the things that are around me. Like it's kind of a similar attitude to Smalltalk. Like, like I don't like the way that the window is, I don't know, has rounded borders on my operating system. So I can go and change it because like I am part of this, like I have as much power as the designers of the system. And I think that's kind of what you get when you're inside of the Smalltalk programming environment. That also means that when you're writing your program, you're able to make tools that you normally wouldn't think of being within your reach, such as like writing debuggers or writing IDEs or collecting statistics about your code, and all when it's running. Like you can make graphs of like how many objects are created or like why garbage collecting is taking so long, or like any number of things like that you'd want to know about your system yourself. I think the first time I saw an idea like that was in Eve, which is a experimental programming language environment by Chris Granger. And the way they achieved it there was with a data log system where like everything in the system is a fact in a database. And so we've talked about this before, where if you want to send an email, it's a fact. Like you write a fact in a database and then the underlying system will send that email for you. And so your code is also a fact. So that means that you can write queries to query your code to see like what the heck it's doing or like how all the pieces are connected together. So if there's like like you have a piece of data on a page, you're like, why is this wrong? You can trace its lineage as everything that have touched it since it came into the system. And in Smalltalk, it's the same thing. Like when you have everything as an object and everything is inspectable, then you can do stuff like that, and it's extraordinarily powerful. It makes you feel like you're in the system and you can touch everything that you see. Yeah,
definitely. And it's something that I highly encourage our audience to look at some of the demos that we're going to put in the show notes, where you can see the user modifying the system in place, adding behavior that wasn't there before in ways that honestly today we don't have. Like if you wanted to build a customized debugger for your program that, let's say, doesn't step through the code at the level of abstraction of lines, but instead operates on some higher level concept, like you wanted to write a web server and write a web server debugger that instead allows you to inspect every request and response that goes so you could build that in Smalltalk. When right now, if you ask me like, hey, I have a web server and I need to debug it at this kind of domain specific level, I wouldn't be able to tell you how to build a debugger for that. It seems like we've sort of regressed in that sense because our tools don't expose themselves the way that the Smalltalk was designed to.
Yeah, one of the interesting things in one of the talks that we'll post in the show notes is that you can build debuggers for your DSLs, and so it's in the level of abstraction where your users would be interacting with, and so that I thought was pretty interesting. Yeah. So the other aspect of Smalltalk that I wanted to go into is the fact that they designed this with the GUI in mind, and that every component that is accessible to the user should be able to present itself in a meaningful way for observation and manipulation. And so by that, they mean that you can have an object render itself in a variety of ways, whether that's simply displaying its own state or its own code, rather, or if it makes sense to expose a visual interface with menus and pictures and things like that. And that seems like something that we take for granted today, but if you look at the contemporary computing environments that were around when they were making Smalltalk, this was a completely revolutionary idea, and I think it led to a lot of the innovations that eventually were taken by Steve Jobs and his tour of Park, and then implemented in the Mac and things like that. But
I think Smalltalk and the environment that it ran on was sort of the pioneer of all those things.
Yeah, I mean, this also ties back to our end user programming episode where we talk about embodiment, because one of the things that you want is for these abstract concepts to make concrete, at least like you should be able to see them, because a lot of times like the way that our programming languages and environments are, even with an IDE, you just feel like you have to play you have to play the computer in your head. Yeah. And in order to see, you have to play the computer in your head in order to see what the computer is doing. And at best, if you have a debugger built into your IDE, you just have to step through it. And if you're a little bit past the point, then you can't actually rewind and like inspect. So you have to like restart the entire thing all over again. Yeah. And so I think with Smalltalk, like everything is already in running, because like with a debugger, it's kind of like it's a shadow of what has gone on before, and it's like a tape that you can only run forward. Yeah. And if you miss the critical part, then you have to rewind the entire thing and go through it again. Whereas I get the sense that with Smalltalk, it's not like that. It's more like editing, like debugging production. Debugging production live, right, is effectively what it is. And so like you can just kind of interact and play with the state of your program live while it's running. And so if something doesn't work, you don't restart the entire process from the beginning. You just like undo it and redo it, or like write the state back to where it was and inspect like what its behavior is. Yeah, totally. And that relates to the fact that in Smalltalk, typically you save your entire program, including its source code and all of the running state, as a Smalltalk image. And so we can kind of think about it today as maybe like a virtual machine snapshot or something like that. Yeah, I found that to be kind of weird when I first heard about it, but yeah. I guess it makes sense. Is the image like a database, or is it just like a... I guess it's just like a serialized version of all of the objects and their state, and so from that you can inflate it back into exactly how it was. Yeah, which is kind of trippy, because it means that you can sort of snapshot your program as it's running and send it to your friend, and they can open it and sort of help you debug exactly from where you were and see exactly what you were seeing. So yeah, it seems really trippy. Yeah, I wonder if that also practically happened, because I know in reading some of the later parts of why didn't Smalltalk take over the world, which we'll get to, one of the issues was there was no standard for Smalltalk outside of like the core, and so when you wanted to send objects to each other, like it didn't seem like it actually worked that well. And so supposedly there was a way to take like an object from outside the system and then like write basically like a interpreter for it, or like something to make it compatible with your own object system. But I guess in practice it didn't actually work out that way. And yeah, I do wonder, because like I guess once you see like the inspiration for this stuff, like I once again saw this sort of thing from Eve, where like the entire state of the application is a database, so you can just send it over to somebody else and they can just debug it if that's the case, because it's got the reflexive properties. And so that seems really powerful, and I guess I don't know why we got rid of it. Maybe in the name of security, or you know, like I can see that being a security issue, or like it's hard to make money on things that are really flexible, maybe. Yeah, I don't know. We'll talk about this later also. Yeah. So yeah, we should definitely go into all of that, and we should caveat this by saying that people looking back on Smalltalk do have a lot of valid points about why it was really ahead of its time, and in fact, it's sort of ahead of where we are today. But yeah, we should like be aware of the fact that it was very much a research programming environment that had many different variants. So there wasn't a single Smalltalk as such. There were multiple versions of Smalltalk, and then as it got commercialized by different vendors into their own sort of fragmented versions of Smalltalk. And yeah, so it was very much visionary, but I think it had its own set of flaws, and so we should be aware of the fact that it did, unfortunately, if you look at it in terms of adoption and usage, it ended up failing. But at the same time, it doesn't mean that it was a failure. I think it ended up being very, very influential in a lot of the things we see today, from anything from day-to-day programming, but also, you can see its influence in things like Eve, in Dynamic Land, which we discussed last episode, and in so many other projects as well. Yeah, I mean, maybe you'll find a revival, because I guess before Clojure, I would have said the same thing about Lisp, right? Yeah. But like Clojure warmed its way through things. I mean, like Rich Hickey was very practical about it. He's like, we got to target the JVM, otherwise like nobody's going to use it. Right. So yeah. So yeah, and then so I guess going back to kind of the vision of OOP, or like the things that are intrinsic to Smalltalk that were kind of different than what we were taught as OOP. Are there other things that came to mind that we missed so far?
No, I mean, I think that's the main thing that I got was the message passing model, as well as the fact that, you see this a little bit in languages like Ruby, where you can modify the classes that come with the standard library. So you can make a method called isPalindrome and attach it to the string class in Ruby, and now all strings everywhere now can report to you whether they're a palindrome or not. And so it seems kind of like a dangerous, crazy concept, but it's how things were done in Smalltalk like all the time. So I think I was a little bit surprised about that. But yeah,
the monkey patching,
sort of the monkey patching, and just like, I mean, I wonder, it's such a flexible environment, but when you actually put it in front of real people, like the day-to-day person, I wonder how that translates, because maybe I've become sort of cynical and like distrustful of the user, and it's very clear that like, the folks at Park were very much like believed in the potential of humans and their creative capacity. But yeah, I wonder, which view of humanity is true.
Yeah, I'm not sure, because my first foray into being interested in languages came with Ruby. Ruby was the gateway drug to looking at everything else. And it seems like with all the flexibility and monkey patching, you would get some really obscene code, but I don't know, for some reason culturally, a lot of the Ruby libraries are pretty great in their user interface. Maybe underneath it's a mess, but it seems like at least the people that write libraries for Ruby seem to have a real sense of what programmer affordance should be like, and they paid a lot of attention to that. So when you're using it, it never really feels terrible. So I don't know. But then again, I've worked with people that wrote terrible Ruby code, so just because the tools are there doesn't mean anything. I think I read one of the papers by Alan Kay called The Early History of Smalltalk, which we'll link in the show notes. He says, you gotta be careful that you think that providing the tools will provide interesting tools will provide interesting thoughts, and that's not the case. The music is not in the piano, and it's possible to graduate Juilliard without finding or feeling it. I was like, ouch, ouch, ouch. Yeah, I mean, but it is true. You do beyond the tools, you do have to care about it in order for it to manifest itself, I think.
Yeah. I thought it was very interesting that the way in which they developed Smalltalk. So in Dan Engel's Design Principles essay, basically he goes into their development model in which they started with the end in mind, which is again this Dynabook tablet that children are able to use as their personal computer in their personal computing environment. And they sort of worked backwards from there, and they were like, well, what would computing have to look like in order for that to happen? And then they were like, well, we need to have graphics and graphical user interfaces, and we need to have a programming language that worked in this way so that they could children could reason about it. And then from there was actually, in the early history of Smalltalk, Alan Kay goes into a lot of the engineering about how they optimized things and represented objects in memory and things like that, so that they could pull all of this off on what was very early hardware. And so, yeah, it was a very principle-oriented way of development, which we don't really see anymore, where you start with a vision of the future and then you make the things happen. You don't see too many organizations working like that anymore, and I think that's part of the magic of Xerox PARC that people are always referring to.
Do you mean programming languages aren't designed that way, or just any software that's being written?
Yeah, I mean, I would say any software that's being written these days is not like, hey, I think that I have this thesis about how the world should look like, and we're going to have to do all of these feats in order to pull it off. We kind of work instead from, well, here's what we can do, and there's sort of this immediate need, and we're going to sort of take one step forward and make it happen.
Oh. Yeah, I mean, I think part of it is just this philosophy that swings back and forth. I mean, I think Peter Thiel does talk about this a little bit, where, well, if you're, he has a quadrant between certainty and uncertainty, optimistic and pessimistic, and in one of the quadrants, which I can't remember which, it's more conducive to planning. I guess it's certainty, and you're an optimist, right? Mm-hmm. You're certain about how the world is going to go, and you're optimistic about the world in general, then you would plan for a particular outcome. But then when the world becomes more uncertain and you're still an optimist about it, then you're going to still try to do stuff, but you're going to do things more iteratively because you can't really plan for what's going on. And you see this attitude pervade through startup wisdom. The standard startup advice is to shoot first and aim later, and iteration speed above everything else. And a lot of it is just on the basic assumption that the world is less knowable than it used to be because it's more complex. And so you won't actually know, and you can't predict. And so the only way to know is to throw something out there and interact with the world. And it's not wrong. Yeah. It's just kind of more like experimental physics, the attitude of experimental physics rather than theoretical physics. Right. And and I think what you're saying is just that we've swung too far in the experimental physics side of things, and not enough people are kind of taking large bets on the theoretical side of things. Right?
Yeah. And I think that the mode of development that we have today that you just described has resulted in incredible value for the world, and more software is being created today than ever before, definitely than was ever created at Park. And so, not to discount that, but it's just such a foreign way of thinking that was probably peculiar to that time, peculiar to the culture of Park and its sort of research roots. But it's just something very foreign from what you read about today about how you're going to develop software.
Yeah, it's less common now, but there are pockets here and there. I mean, like if you look at Brett Victor, who is kind of the, what's the word? Ingenue? No, the spiritual successor to Alan Kay, like Dynamic Land. He's thought deeply about like what this sort of stuff means to him, and like he doesn't care about programming. He cares more about like systematic thinking and stuff like that. And so he's kind of taken on that mantle. The people at Darklang, like they're inventing an entire language and also programming environment for deployment on the web. They seem to be more thoughtful about the tack that they're taking as well. Although, like, I don't know a lot of the details. It's just an impression given the things that they put out. Right. So I think there are pockets here and there, but for the most part, I think people just throw it out there and see what happens.
Yeah. I mean, so actually, I'll throw it back to you. What were there other aspects of Smalltalk that you found surprising or that you didn't know?
Well, I'm glad you asked, Rhea. I think one of the things that was surprising when I was doing research for this podcast was the idea that the objects are meant to be places in which you work out the high-level interactions between the things that are operating in your domain. So, like, people talk about, like, writing stuff as a DSL so that you can operate at the level of abstraction for your problem. And I've found that in practice, people have a really difficult time doing this because, like, when you're programming, it seems like most everybody's first goal is just to get it to work first, regardless of how it's put together. And then if you don't ever have to like revisit it, then like it never actually gets abstracted out to anything. It's just left there for like the next dude to find. And then when the next dude finds it, he has to like, or dude or gal, I guess, and then like a lot of it is stepping through, trying to figure out like what is going on, and then their job is to like add a layer of indirection for the next guy to find, like next person to find. So I don't know in practice whether that kind of panned out or not. I think the other thing that was interesting was the idea that the methods for the objects are supposed to be goals, which surprised me for them to be described that way, because it's goals in the relation, like the logic programming sense. Like the declarative logic programming sense, because like the design rule of thumb for object-oriented programming that I've always heard was that you have to design methods that make it seem like you're requesting the object to do something for you, so you're like delegating to them. But I think the intention was always that it's a goal, like in a relational sense, like a logic programming sense, and so that you're able to make these things work together so that you declaratively, and that I think was missing in a lot of the design aspect. And then
actually, so that reminds me, in the last episode of Dynamic Land, part of the Dynamic Land design, the design of Real Talk, is they have this concept called, I think, wishes, where you can wish the world to be in a certain state. And I wonder if it sort of harkens back to this, or at least it seems familiar to me when you say goals.
I do wonder. I do wonder if there's some relation there. I wouldn't be surprised, since like a lot of the more detailed essays I found about Alan Kay and the things that he wrote came from Brett Victor's references that he kept around. So in his own research years ago. And then I was going to say the last part that hit me was less to do with the object-oriented programming language itself, but kind of the whole goal, which was how to empower end-user programming. And so Alan Kay has a story about how he tried to teach Smalltalk to 20 like non-programmer adults when they were at Park, and they were able to get through the initial material faster than the children. And just as it looks like they were going to have overwhelming success, they started to crash on problems that didn't seem like they were too much harder to Alan Kay. Mm-hmm. And like one of it was just like build out a Rolodex database sort of thing. And so that night he went back and he wrote it out himself. The next day he went and showed them all how to do it, and then still none of them were able to do it by themselves. So he's like, okay, let's sit back, and he tried to figure out like why. He counted the number of non-obvious ideas in this program, and he counted 17. And so he was like, oh, like it's not enough to teach people the equivalent of what numbers or like letters or words or paragraph are in order to achieve literacy in reading. Like you actually have to get them familiar with literature, because it's the literature that renders the ideas, right? Because like some of the non-obvious ideas were like the concept of an arch in a building. Like it's hard to discover if you don't know them already. And I guess this is what the Gang of Four tries to capture in design patterns. And like I said in a previous episode, like when you first read it as a novice, you're like, I kind of get what they're doing, like how it's put together, but I don't know what to use it for or like when to use it. Right. It's not until like you've seen those things, you're like, oh, okay. And I guess it's the same with monads, and that's why you get like those monads are burrito sort of thing. Right. But anyways, to the point that like there are these like patterns, and like it's the literature that renders ideas. And so it's the organization of ideas that start to dominate your ability to have new ideas. And it's not just the mere language abilities. And so that's when they started to try to teach design. When I read this, I was just like, why did this not filter through to like all the rest of the universities? Like, where was Alan Kay putting his effort? Because I did not get any of that in my university training and stuff like that. Yeah, I mean, even as a professional software developer, I don't think I've received too much training in how to design systems, or how to break down a problem so that you can model it in software. And so I've learned a lot of specific nitty-gritty things, but never that. Yeah, and it's kind of hard to communicate too. Like we don't have the equivalent of like classics. Like the only thing I can remotely think of as a classic is maybe like the Quake source code. Like people want to keep that stuff around and like review like things like that. Yeah. But like we don't have, so like people can see how like the square root was computed. Yeah, fast inverse square root. Yeah. And Right, the fast inverse square root, or like BSP trees. But like we don't really have the equivalent of like a body of literature of ideas, because most of that stuff is written in blog posts outside of the computing medium itself. And so when I read that, I was like, oh, like it would be really great if libraries were explorable in the same way that you can debug your own programs, like without like having to pull it all in. Yeah, I think that people sort of reference this idea of reading great code bases and things, but the way that we do it now is maybe you go to GitHub and you click around on the source code of some project that you're familiar with and sort of try to absorb through osmosis, like, oh, okay, this is an interesting concept or something like that. But I imagine that it's a much more different experience in Smalltalk, because you're not just looking at this sort of rendered dead source code. You actually get to look at the behavior of the system and say, okay, like let me inspect how this is running and maybe change it a little bit and see how it changes the outcome. And so that seems like a much better way to get exposed to great programming ideas, by actually seeing them work and watching how it runs. Yeah, and so like I feel like I've gotten my experience mostly by designing projects from the ground up. And I remember like early on when trying to write my own games, like it could teach me all the kind of the low level stuff, but I had no idea how to put all the stuff together. Like I didn't know how it was supposed to hang together architecturally. And then when I started building like web projects, like having a little bit of structure in place helped, like Rails. But when you start building things outside of the CRUD app, like you have to do some work to think about like how should this thing hang together? And I think it's, for me at least, it's only through the process of like making these decisions and seeing what the outcomes are that I've started to build up an instinct for like what might work, what might not. And I wish it was a little different way to obtain that knowledge. And I don't know, maybe there's no other way, or maybe like reading great literature would have helped that instinct. And so if it works in reading and writing, I would think that it would work in programming. So anyways, that was a part that really jumped out at me as well. Very cool. And now I feel deficient in my programming skill. No, I also feel completely illiterate in some sense, right? Like you shouldn't consider like being able to read like pill warnings on a bottle literacy, right? Like that's not like a deep idea that will help you have a deeper appreciation of the world. And so in that sense, I mean, like maybe I'm still like illiterate when it comes to computational ideas. And
if we're illiterate, then what's everyone else, right?
Yeah.
Crazy.
I don't know.
Okay, cool. Yeah, lots of things to unpack there, but I do want to transition into just the question of, has the vision been achieved? Like, how did the vision go? And there's some interesting write-ups from people who were involved at the time about how, the commercial adoption of Smalltalk and more specifically, spoiler alert, by this time you've probably figured out why Smalltalk didn't win. We're not all using Smalltalk right now, and so there are a lot of interesting reasons.
Yeah, and so has the vision been achieved? Are you asking me
I'll
ask
you. Yeah, what do you think?
Well, so I guess there's a couple. In terms of like improving the children at the time and making them into adults that are fluent in computing to be able to help solve the world's problems. I don't know. I feel like if it has, it's reached a minor number of children who are now adults. I mean, there is a guy, Steve Krause, who's running the Future of Coding podcast, and he talks about how he went through a program learning the Logo programming language, which was created by Seymour Papert, who was an influencer, not an influencer, an influence on Alan Kay and his thinking for like teaching children like computer literacy. And, it worked for him. Like he thought he was bad at math, like Steve Krause thought he was bad at math growing up. And like after the program, he felt really confident about using computers to help him understand the world. And so I think if it worked on a minor number of children, because I don't get the sense that most children are like that. Yeah. Like most children can use computers today, but they're
sort of in a read-only sense, though, right?
Yeah, in a read-only sense. Like they can work it, but I don't see them using it to model the world. Like unless they're like programmers themselves, or they're using spreadsheets. Like I really don't, or like playing with Raspberry Pis or something like that. Like I don't really see it. So in that sense, I don't think so. Yeah. But maybe the minority that did it, they went on to be very influential. So maybe I'll give that a maybe.
Yeah.
In terms of OOP, I would say that the Java line of OOP has not been a success. I feel like programming has been even more complicated with the problems that object orientation has introduced. And so some of the things that Alan Kay extols as virtues in object oriented, it turned out not to be the case. Like multiple inheritance, I think most people understand to be like problematic nowadays. Yeah. I think where there is success is actually in Erlang, in the actor model. Yeah. I think that's where like the mantle of OOP should be considered a success. And so that is probably where it is. It's successful in the sense that at least it gave a way for people to organize their code, because I can imagine that before OOP, it was mostly procedural programming, and before that it was GoTo. So it could, if it was a mess, if it's a mess now, it probably was even more of a mess before. Yeah. And I think people weren't really ready to embrace functional for some of its benefits that people are just only seeing now, I think, in the mainstream programming, I think. So in that sense, yeah. So my last point is where it did win is that it's rich, full of deep ideas that people are still mining today for new programming systems. And it was far ahead enough that decades later, we're still looking at it to see what we missed. Because like when Steve Jobs came to it and like took GUIs, which were originally meant as a programming environment, but used it for like userland, and he saw like object orientation and, created languages like, I guess Objective-C is a successor to that kind of object orientation tradition. But like it didn't focus on the message passing part as far as I know.
Less so.
I don't know.
It still has a concept of messages though, but yeah.
Right. But like all the focus on OOP has been on message pass inheritance. Yeah. And so I don't know. It's a mixed bag, but when it comes to influence, I think it's definitely very successful. So that's my like 3 long bullet points. I guess.
No, I like it. Yeah, I totally agree. I think that as a sort of concept, as a vision of how computing could be, it played a big role in shaping, the languages that we have today, the environments that we have today. You see a little bit of its influence in many languages: Ruby, Objective-C, even Swift, carries those on as the successor to Objective-C, which is sort of descended from Smalltalk in a way. So yeah, I mean, I think it has spread some of its ideas in a diluted way, and unfortunately, Smalltalk itself did not find success in the marketplace. It seemed like there was a time in the 90s where there was a potential, because before Java came out, there weren't too many ways to build that kind of rich interface, rich GUI interfaces using a powerful language. And so there was a time when it seemed like many enterprises were transitioning away from sort of the DOS terminal applications toward GUI interfaces, and Smalltalk sort of positioned themselves as the solution to that. But then as soon as Java came out, and then later as soon as the web sort of came out, the sort of demand dried up. And so basically all the things that Smalltalk was good for at the surface, which was building GUIs, got sort of eaten up by these other more, I guess, flashy solutions. And then it turns out that most of the people just associated Smalltalk with GUIs, and so that once that problem was solved, they sort of abandoned all the rest of the stuff about end-user programming and empowerment and this and that.
Yeah, we'll put it in the show notes. Like this, there's a blog post about why Smalltalk failed, which is where we're getting this from. But I thought it was interesting in how some of the stuff was interconnected. Like Smalltalk, as you mentioned earlier, was a research programming language and programming environment. And so when you read Alan Kay's stuff, he makes it seem like it's just ready. They did a lot of the work, and not saying they didn't, right? They had to invent a lot of that stuff, but in order to take what they've already invented and then also push it to production environments, there's still some ways to go. And so apparently the companies that wanted to take Smalltalk into the marketplace, they felt like they still needed large engineering teams to take it into production. And because of that fundamental, I guess, need to do that, then they felt like they needed a lot of money. Where are they going to get a lot of money? Well, they need to go sell to enterprise. Yeah. And the thing that they ended up figuring out, presumably by talking to customers, is that enterprise, they didn't really care about all the reflection or end user programming sort of stuff. They just wanted, like you said, to turn a thin client into a fat client with the GUI, because that was what was trendy at the time. And so because the Smalltalk guys were so focused on that part, that they got blindsided by the rise of the web and Java, and Sun Microsystem being the party company that they put a lot of marketing muscle behind Java. For those of you that didn't grow up in the 90s, there was a lot. I don't think there's been any programming language then or since that had so much marketing prowess behind it.
I remember being a kid, and my dad would go to conferences, and he would bring back so much Java swag. Our house was full of it, and I loved it as a kid. But yeah, thinking back on it, they were going all out on promoting that language. Nobody promotes programming languages that way. I wish I would get some programming language swag, but yeah, man, what a time it was.
Yeah, and so they pushed it hard, and it was a combination of being, well, at least for Java, being at the right place at the right time, and Smalltalk being so focused on doing the conversion that they got blindsided by that, and just haven't recovered since. And so I think that's one thing. Yeah. And the other interesting thing that I read was that Smalltalk has its philosophical origins from Lisp. They are the type of programmers that care more about representing computation and exploring the limits of computation rather than being hemmed in by what computers can actually do today. Mm-hmm. And so they, like you said, work backwards, and then any part that was actually slow, then they would kind of go down into the microcode and optimize that. And so what they wanted to do was they wanted to evolve the language, but by building the language and then putting applications on it, and then seeing how that was or wasn't being served by the underlying language, and then improving the language and having that virtual loop. Yeah. But it wasn't that wasn't the only virtuous loop that they wanted. They wanted that same virtuous loop with the hardware, right? They wanted the language environment to inform hardware, which then would improve the language again. Mm. And so that's what they wanted. And so that's where the Steve Jobs, quoting Alan Kay, that those who are serious about software would build their own hardware. Yeah. But in that context, it's actually it doesn't provide the spirit of the quote, because like Steve Jobs just used it to sell more computers to say we're vertically integrated, so we're better, right? But in actuality, like what Alan Kay was talking about was that virtuous loop. Like he wanted that to be like an ongoing thing. And so as evidence of that, like what they did was they released Smalltalk images to various like companies that wanted to license it, and they hoped that these companies would build their own hardware to help support Smalltalk.
Yeah,
right?
actually, like a Smalltalk specific processors was the hope.
Right. And so like if you can imagine, like one of the things that people rail against nowadays is for certain type of applications is like garbage collection, because you get pauses from garbage collecting all the objects in memory. So like things like, I don't know what it is, Rust doesn't have a garbage collector. Like they just pre-compute everything ahead of time so that you don't need to at compile time, so you don't need to collect any garbage. And so I get the sense that like what Alan Kay wanted was like, how about you build some hardware that does garbage collection, say in a different thread or something like that, so that we won't get these GC pauses. Like that's what he wanted. But like these companies, obviously to cut costs, they're just like, well, F it, we'll just build these on commodity build our like machines based on commodity hardware to run Smalltalk. But as it turns out, like it was just too slow to do anything, and so some of them just pulled out as a result. And Alan Kay and them were like, "Oh, what are you guys doing?" Right? But they should have seen that coming. Like people are gonna try to take the economical way out if they can get away with it when it comes to entrepreneurship, right? And so yeah, I mean, like that was something kind of that jumped out about like why they failed in this particular area. It was a combination of circumstance, bad luck, and kind of bad anticipation of what people would do.
Yeah. And yeah, I'm really curious about this aspect of whether Smalltalk was networked, and maybe we'll look it up and we put something in the show notes. But
well, the Alto computers were networked.
Yeah. I mean, specifically, I'm trying to figure out, like the web later came and ate everybody's lunch, right? Like even Java now is no longer used for at least front end software, but for the most part. And so I think that this kind of environment with a very fat client and its dependence on the hardware, the whole thing got flipped, where now the web was a sort of thin client, and you can make no assumption about the hardware on which your software would be delivered, because it's delivered over the network and it's just going to run, and so now everything is virtualized and stuff like that. And so, like the whole computing model actually went in a very, very different direction, and so I think that sort of threw a wrench in the works.
Did it flip back? Because I feel like the thick client kind of swings back and forth every. I mean,
I guess like mobile apps then flip to thick clients, and
right.
Maybe the pendulum will swing back. Yeah, I don't know. I guess
the blockchain. The blockchain is the new server.
Yeah, now everything's a thin client over the sort of global computer. Yeah. So I mean, there's just so much like fashion, marketing, pop culture that all of these big ideas really didn't like hold up against the messiness of reality, which is you can think about it as unfortunate. You can think about it as that's actually that's competition and capitalism and whatever your thoughts are on that. But like,
no, I mean you have to survive in the marketplace. Like unless you're really good at writing grants, I mean like you have to survive in the marketplace somehow. I mean even good ideas. I mean. Yeah, like the whole reason we have an economic engine of capitalism is because like it makes people do stuff that is for the benefit of other people, right? To make money, at least. Like I'm not saying people are not self-interested, but the result is that you get stuff that other people can use. But like it has to have a very certain shape to fit the like economic model of our world. Otherwise, the idea would only exist in academia or in people's minds, or maybe in art, or in fields in which like the unit economics doesn't really figure into it, and it may not usually. Those sort of things don't pervade nearly as widely or as well. It depends. Obviously, there are a lot of exceptions.
Right. Yeah, I totally agree. I think that there's definitely a disconnect between the culture of the people making Smalltalk and then the culture of the world at large. And actually, that touches upon what we talked about.
And sometimes necessarily.
Yeah. I mean, it's true, right? Like you don't get really, really far-thinking ideas largely, without sort of being disconnected from the day-to-day realities. And actually, that connects to what we discussed last episode, where we discussed Dynamic Land and them keeping their Dynamic Land under wraps with very, very little press, very, very little sort of oversight into how it works. And they did that as a deliberate design decision because they don't want what happened to Smalltalk to happen to them, where people come in before it's ready, before they have a fully formed sort of vision of how they're going to execute on this, and have the bits and pieces sort of parceled out and bastardized the way that Smalltalk introduced OOP, and then Java just stole OOP and made it into some whole other thing. And so it's kind of an interesting callback to that.
Yeah, when you read like Alan Kay's writing on the early history of Smalltalk, the bitterness really comes through. Like it's like you feel that he had these other goals. Like Brett Victor has called him the greatest philosopher of our time. It's just nobody knows him for that. They just think of him as this OOP guy. And I think it's partially that, where I think he had a vision for not just Smalltalk, but like he cares about like how to make computing literacy or like systems thinking like one of the 4 or 5, whatever the R's are, reading, writing, arithmetic. Yeah, the fourth R, right? And so Smalltalk may not, like, he wanted to like restart like that project that using Smalltalk. It's like Smalltalk's like close, but it's not actually quite there. Like it wasn't exactly what he wanted. But he saw that like those things have pervaded out in a bastardized form. I don't know, what's the best idea you've ever had, Sri? Like, and then how would you feel if like you got the like a bastard version of it out there, and people like thought that, I don't know, like you invented basketball, but everybody feels like it's about the shorts or the shoes.
Right. So. Well, I mean, I would feel a little bit sad, but at the same time, this is a pattern that I've seen happen over and over again, and especially with these big ideas about computing and self-expression and things like that. Like, people start with these huge ideas, but I think that they are so different. The diff is so much between where society is now and what some of these people are thinking about, that the most that can be absorbed at one time is like one unit, one meme from that whole big vision. And so we're just going to take like one small step at a time, and that like you kind of just have to accept that, that's success, I guess. Like that's my take on this.
Yeah, I mean, in the episode on Dynamic Land, like you quip that, like creators should be okay with like people taking things and making it their own when it's out in the world. On one hand, I do agree with that. Like it, people will surprise you, both good and bad, I guess, right? And so like they can find applications that you wouldn't have even thought of. But on the other hand, I do sympathize that if there's something that is so, it's not just like 1 or 2 steps removed from what people currently know, but like 3 or 4, like you want people to get there at like the 3rd or 4th step, right? And to be able to like fully utilize the ideas that you have. But it's just so hard for people to make even one leap. Like smart people can make 2 leaps, but like most people do not like make 3 or 4 hops from where they know, unless they've been immersed in it for, I don't know, years and years, right? It takes a while to come up with those ideas that we think of as obvious once we've accepted it. But like those are the sort of things that you get burned at the stake for.
Yeah, definitely.
And so, like you said, it does take a little bit of time to kind of get there. And so that's why like people still go back to Smalltalk and Lisp to like mine it for ideas, because there was a couple leaps.
Right. Yeah, and actually Alan Kay did an AMA on Reddit, I think back in 2016. I was reading some of his comments today, and somebody asked him, everybody asked him about Smalltalk, but like in response to one particular thread, he said, Smalltalk was a really huge deal back in the 70s, but you should really ask yourself, why do you even care about it today? And what I got out of that was basically like, Alan Kay is over it. He is like, there's a bigger fish, there's some bigger vision that he has today, and I'm very curious what it is, but like, like we are all here, like, a generation later, inspired, looking back at Smalltalk and trying to make like little bits and pieces of it happen. And he's like onto the next thing. And I bet like if we were to hear his vision of what the next thing is, we would also just like not understand like the depth of that thought that goes into that.
Yeah, I mean, I've seen some version of this. Like his current research institution is called the Viewpoints Institute, I believe. And he's... One, I think he needs a better graphic designer for his slides, because they all look terrible, and I don't think they not just look terrible, but they're too cluttered to convey like a single clear idea. And so I think he has some problems communicating in that sense, if they were a little bit clear, one. But I think two is that like the ideas that he finds difficult to express because we don't have words for them. He's trying to find what they are. And I think one of the things that I got since the reason why it's called the Viewpoints Institute was because he's trying to find tools and ways of thinking that can help us change our point of view to make a leap into new ideas. And so that if you're able to kind of break out of your local maxima to have different viewpoints, like he's often quoted as like a new or better viewpoint is worth 80 IQ points. And I interpret that to mean that if you have like better tools for thinking, or like people recently, what's his face? Linus Lee, I think, wrote a blog post about notational intelligence, that, you know, the thinking tools that we have that made giant leaps in civilization are things like the Arabic numerals, is one, like, and like, what's the other one? Other notation, math notations, and I guess reading and writing, like just being able to write stuff like those have made considerable leaps in civilization. And so I think what Alan Kay is trying to do is create a similar leap for civilization so that we can kind of get onto the next plane of thinking.
Okay. Yeah. I mean, that sounds like exactly the kind of far-reaching, you know, vision that I expect from Alan Kay. And me being slightly cynical will imagine that somebody will carve off a piece of that and sell it as some kind of, you know, enterprise thing.
And we're supposed to be optimists on this podcast, but yeah, I mean, it's true. I think like just commercializing it isn't necessarily a bad thing. I guess it depends on your viewpoint, but like we said, like in order for it to be pervasive and democratized, like the unit economics has to work somehow. It has to be something you care about. Like you and I have worked in startups. We know just how hard it is to find things that like people want and are willing to pay for, and like it has to solve their immediate problem. And that's kind of a constraint. Like you can't solve people's problems that they're going to have. You need to solve people's problems today in a way that they understand.
Yeah, actually, I mean, you know, to pull it back to optimism, I think one thing that I found really interesting was that a lot of the software tools that we use today, that we think of as just sort of productivity software, was inspired by these views of computation. And so one example that comes to mind is actually Notion. And really early in the history of Notion, they kind of paid homage to these early computing pioneers. Actually, the Notion blog still has, you know, really great in-depth interviews with some of these folks from that time. But yeah, I mean, ultimately, you know, we think of Notion as an interesting kind of document where you can embed all kinds of, you know, tables and interesting things. But, you know, if you squint and you look at it, it's a dynamic medium that people just now are ready for, like this idea that a document can be sort of living and can have its own state, and you can represent your ideas in different ways. And so, I mean, I think that it's not necessarily a bad thing that people sort of carve out the one thing that people are ready for and introduce it. And you know, step by step, we kind of get to this larger vision.
Yeah. So I think like we mentioned in an earlier episode that like the intellectual lineage of Smalltalk is not apparent unless you kind of know where to look, or that you can recognize it, and it's dispersed throughout. So yeah, like, and sometimes hiding in plain sight.
Yeah. So I mean, it's definitely cool. I think, you know, in researching Smalltalk, there are still Smalltalk environments today that you can go and download onto your own computer and try. And actually, there are lots of new adaptations of the concepts of Smalltalk that people are trying to bring to the web. So there are a few projects that I'll put in the show notes, like Lively and Caffeine and things, where people are now trying to bring this idea of an observable, on-the-fly interactive environment to the web browser, which makes a lot of sense because the web browser is also that kind of environment. And so making it so that you can sort of live program within your browser. And so, there are lots of like intellectual successors, spiritual successors to Smalltalk. There are also actual successors to Smalltalk that are trying to bring Smalltalk itself into the modern era. And so it'll be interesting to watch, and I encourage people to go check those out as well.
Yeah. So if only to experience it, but I guess the best thing is to watch somebody demo it and know what you're looking at, I guess. Hopefully somebody's narrating what you're looking at.
Yeah. Cool. I mean, I you know, we usually ask ourselves, like, whether we're feeling optimistic about the technologies that we're looking at in the future. And I think that I feel like my summary of Smalltalk is that it was definitely something that's hiding in plain sight. Like you said, it's a huge influence. And so I think it's to kind of recap, I feel retro optimistic. You know, I like looking back, I'm like, their optimism was well placed. I think that it was the right thing to have worked on, and, you know, we're all better off for it. And so, I think it's super cool.
Yeah, I researching Smalltalk and stuff, and even before that, I was watching the Brett Victor stuff. I realized that programmers we think of ourselves as a relatively young medium, and so we don't really examine history like at all. There's no such thing as like programming or computing history in university courses, and I think that's a little bit of a shame, because like we have the bold ideas from when computing was first starting, and so back then they were just like, we don't know what we're doing, we don't know what computing is, and we don't know exactly how to program computers, so we'll just try all sorts of stuff. And so there's a lot of ideas there that I don't think a lot of us still know about, like, and we reinvent the wheel over and over again instead of like understanding, oh, okay, this thing rhymes, like how does this apply to the computing environment that I have today? And so yeah, like I would encourage people to go look at it. And in terms of like how I feel about it, I feel thankful that Smalltalk was invented, and you know, I'm optimistic that we'll still have plenty of ideas to extract from it before we really move on.
Very cool. And with that has been our first Retro Future episode of the Technium, where we went into Smalltalk.
Yay!
Yeah.
Yes, jazz hand.
Yes, so come back next week where we're going to be talking about another new idea in the edge of computing.
Awesome. Yes. Subscribe, hit that bell, whatever it is, and we will see you next week at the Technium. So this is Will.
This is Sri.
And signing off. See y'all later. Bye-bye.